Okay, good morning children. Today it is going to be a session where you will clearly understand what exactly is the role of software testing, or you can call it even embedded testing. This is done specifically towards the upcoming placement process that we are going to attend, and this will be very helpful for you to understand the complete flow. So I am not going to give you a lot of inputs with respect to how do we do, but instead I will tell you the fundamentals of it very clearly. The session is all about telling you what exactly is testing, how important is a tester's role, what is the difference between verification and validation, what are all the steps involved in the software testing life cycle, what are all the types of testing, how to write a good test case, and how do we write a test case which is acceptable in the market. So all these are going to be seen completely today, and I will show you a lot of examples. And finally, I will also tell you how important or how much important it is to go ahead with a good sort of debugging, as well as how do we write a good test case. I'll show you a very simple test case example there. So please let me know in case it's not audible, or in case you cannot understand. You can type it in the comment section. I'll happily answer your questions. Now if you see this picture, this is taken from internet. If you see this picture, what is the role of developer? The developer will always think that how can I make it. What is the role of tester? The tester will always think about how do I break it. This is their respective roles. They weren't so much different, but the goals are extremely different. The tester will always try to find faults. Why do we have a tester thinking that way? If tester is not thinking that way, the customer will think that way. So we are selling the product to the market, we are selling the software to the market, and in case the product fails in the market, it is the responsibility of the company to answer it. So instead of someone else failing it, let's have a team inside, and the team can test the product completely, and they can gain confidence that this won't fail in the market, is what we all need to understand. So the developer develops the product in all aspects, gets it to a complete level, but the tester will think about it, how to break it, and he will go to the extreme, and the tester will go to the extreme corners to understand if the product will fail. Very simple. The software development life cycle is very important. Some of you might not have gone through it. So I'll tell you how exactly it works in the software. Having worked in the industry for some years, I can tell you this clearly. First, when we want to build a software, we need to collect the requirements. It is like very simple. You are going to the market to buy vegetables. Before you go to the market, what will be the first step that you will do? You will try to understand what are all the vegetables that you want to buy. Is that the first point? Correct. You will have the requirements clearly put into the paper, and you will make a note of it, and you will go. And then what is the next step? The next step is to design the software. Okay, what do you mean by design, sir? I'll have to understand what are all the modules, what are all the functionalities that the system is going to give you, what kind of input I will have to give, what will be the output that I will get, what are all the features that the software can get, how much memory that it would occupy, all those kinds of things will come into design phase. So what is design? The same example I can take. I have bought the vegetables, the requirements is very clear right now. And what I have to do next, I need to understand what is the thing that I am going to cook. Am I going to cook this? Am I going to cook that? I will have to now come into a mind map very clearly that this is what I am going to cook. I will keep things ready for that. And then implementation. I will start coding. The software is all about coding, right? You need to code. Similarly, what I will do, I will start cooking. Well, what will happen the next step? I need to verify it. If the software is working fine, if the software is working fine the way the customer expects, if the software is working fine, the company expects, all these will be coming into picture when you verify it. Similarly, when you come to cooking, your mom or I or anybody whomever cooks for that matter, we will taste the food to see if things are fine. I will just dip my finger and I will see if things are okay. So I will check each and every item like that. So it is called verification. And finally, if there is some bug, excuse me, if there is some error, if there is some feedback from the customer saying that this feature is not working fine, I will have to go and maintain it. Similarly, if somebody is telling that if there is a little bit of salt which is missing, I will have to add salt. If they say that sugar is missing, I will add sugar. That is called maintenance. So what do? We analyze the requirement, we go with the design, we implement it, we verify it, we maintain it. This is what is happening in the entire software life cycle. This is very simple and very easy for somebody to understand. Now, where do we have the testing coming into picture? Very simple. testing is one of the most important wings in software industry. I'm telling you this very strong because I had been a tester. I worked with the topmost products, and it's very important. Without having the testing done properly, the product cannot reach the market. And take any industry for that matter. You take software industry, you take embedded systems industry, you take artificial intelligence industry. Wherever you go, the testing will be done in a very rigorous manner in order to gain the confidence from the maker side, from the product engineer side, that this product can be released to the customer. So testing is all about gaining confidence. It's all about gaining confidence. That's all. I need to build something and I need to sell it to the market. Before I sell it to the market, I should be in a position to tell that, well, this won't fail. So for that, you need to have confidence, and that confidence is what is brought into you through testing. Testing eventually gets you confidence. That's all. So we'll have to define it very clearly now. Why do we need testing? What are all the definitions that are connected to testing? And we need to understand the entire process of testing. Testing, first, as I told you, will get you confidence. I mean, if I am designing a system, does the system work the way it is designed? Second, also the developer has to fix all the bugs before it goes to the hands of customer. So the testing team or the tester eventually gets all the details of the mistakes, bugs, functionality errors, all those in hands to the developer so that the developer can fix it. So it is also connected to the quality of the company and the pride of the company. I am releasing a product. The product should not fail in the market. If it fails in the market, that's all. I will be trolled. So I need to make sure that I save my pride and the repute that I have for the company, and testing will help me in doing that. And most important point, if I detect an error or if I detect a feature failure well in advance, if I start the product and I go step by step, I test it step by step, and if I detect an error, I could correct it right in that stage instead of I going to the longer level. I mean, I wasting a lot of time and finally I saying that this is not correct right now. Testing will help me in doing that. Testing will help me analyzing if we are doing things right, and we can go step by step as well. So to confirm it, to give you a picture in one or two lines very clearly, to confirm if the developed product is meeting the requirements, to confirm if the developed products is not breaking the existing functionalities. I am developing a product that is a sub-product with other products. It is one of the functionalities. For example, I develop a camera app for a mobile phone. In addition to that, there are other apps which are available in the mobile phone. So my app should not make other apps disturb. So I need to test that. And this will remain successful in the hands of the customer. That is one thing that I need to definitely understand and I need to go about. I need to definitely find that. I need to definitely ensure that this product will not fail in the hands of customer. Right. Now, just now I am going to the definition. All this time what I told you is simply the picture about software testing, the picture about software development life cycle. Now only I am going to tell you the definition. Software testing is nothing but a method or a process through which one can evaluate a system. It can be software. I am going to evaluate a system. How can I evaluate, sir? I can evaluate the system through manual methods or through automated script. I can have manual methods into picture. I can go ahead and test it manually, or I can develop some scripts with Python or scripts with TCL/TK or something like that, and I can test it. And I test it to see if the requirements are not deviating from the expected one. I wanted to cook it this way, and do I get the result as expected? Does it deviate? All these are going to be understood. And if there are deviations, it would reveal the difference between the expected results and the actuals. So I wanted this result, and what I am getting is this result. So is the difference so huge? I will identify the defect. So we are concerned about the verification, the validation, and the defect identification. All these 3 points are very, very important. Now we need to understand the difference between verification and validation. This is a very important interview question, children. So please listen to it carefully. What are all the differences between verification and validation? Verification is done to check if the software is being built right. Understand? If the software is being built right. Validation is different, where it will be enabling the user to understand if the product is being built, if the product being built is the right one. Are you building the software right? Are you building the right software? Both are different. Validation will tell you, are you doing the right work? Verification will tell you, are you doing the work right? That's all. I will tell you if the software is being built right. I will tell you if you are building the right software in terms of validation. This is a very, very important question when it comes to interview. So they will ask you differentiate verification and validation. Verification will be done at very earlier stages. It will start in the earlier stages, but validation can be done at midway and above that. Once the code is ready, I can start validating. And very important point to notice, verification is just not for code. Verification can be for design, verification can be for requirements, verification can be for documentation. But when you come to validation, it will come in the perspective of the product. I have a product, I need to test it, so I need to validate it. It will come in the perspective of the product. And verification can be carried out by developers. The developers themselves can, the coders themselves can check it. But validation definitely needs a tester's mind. I am a tester, so I know how to break it. So the tester will always want to break it, and that is where validation coming into picture. Validation is coming into picture. That's all. I hope I clarified the difference between verification and validation. Verification will tell you, am I building software right? Validation will tell you, am I building the right software? Both are definitely different, and I expect you to understand the difference. Now, what is defect, sir? Very simple. You are identifying a bug. You are identifying a defect. Can you define a defect? Very simple. This is what I expect the product to be. The hammer should be like this, but it is broken. This is the result. The difference between the expected one and the real one, and the one that you got in hand, is called as a defect. That's all. I wanted the software to work like this, but the software is working like this. So this is called as that defect. Please understand the difference. Now I have given you a clear picture about what exactly is software lifecycle and what are all the needs for testing to be done. What is the role of the tester? I explained you that as well. I defined clearly the verification validation difference. Now it is very important for us to understand the process that is involved in the software testing lifecycle. What are all the stages that are involved in the software lifecycle, testing lifecycle, is what is to be discussed now. Please understand. The earlier component that I discussed with you was software. It was SDLC, it was development lifecycle. Now it is testing lifecycle. The question can be like this: what is the difference between software development lifecycle and software testing lifecycle? Software testing is part of software development. In fact, the entire cycle needs to be part of the software development, and that's how you need to understand. But software testing lifecycle is important to be understood, and I am going to go step by step. I think I have spent about 15 minutes right now, and we are going to spend another 15-30 minutes for us to clearly understand the software testing lifecycle. There are 6 steps involved totally when you come to software testing lifecycle. First, you need to collect the requirement. Second, you need to plan. Third, you need to write the test case. Fourth, you need to set up the infrastructure. Fifth, you need to execute the test case. Sixth, you need to close. Sir, you easily said it, sir. Yes, I easily said it. We need to detail it a bit, and that's what I am going to do right now. Till now, do we have any questions, children? Anybody has got any questions? Anybody has got any questions? Please let me know in that case. Okay. If you have no questions, I can move forward. Requirement analysis. What is requirement analysis? Very simple. I need to first understand as a tester what are all the requirements that the product has to meet. I am building a product. I am giving it to you to test. So I need to understand what are all the things the product can do. So this can be understood by having the discussion with the developer, the discussion with the client, the discussion with the design team, and you need to understand whatever product is being built will meet all these things. I am building a camera, and what are all the things it can do? I am building a phone, what can it do? So what are all the requirements that is expected out of the product that is to be tested? And most important point is the requirement can be functional as well as non-functional. This I will talk about a little later in a detailed manner. The functional requirements are to be tested as well. The non-functional requirements has to be tested. Now understand, there are testing which can be done by automated suites, which means we can use Python, we can use TCLTK, we can use anything like that for testing the content, testing the code with the software. It is called automated testing. Or no sir, I want to test it myself. So when you do that, it becomes manual testing. That's all. So what is the first step? The first step is to understand what are all the requirements. I need to understand, have a clear view about the software, as in what the software will do, what are all the functionalities that the software is going to give. I will understand this through a lot of discussion with the developers, with the clients, with the design team and more, so to understand what else, what completely can the software give you. So this is the first step. Now second step, you have understood what are all the requirements. Now what is the subsequent step? The subsequent step is to plan how to carry out the testing. Well sir, I have got clear understanding about what are all the functionalities that are available, but now it is time for me to go ahead with the testing. But before testing it, before going ahead with the testing, you need to plan for testing. You need to plan as in how long to test, how to test, who will test, which are all the functionalities to be tested manually, which are all the functionalities to be automated, when to stop testing. You can keep testing the product until you die and until I die. That's the way things are going on actually. So we can do that. But where to stop? You can never stop it if you do not know where to stop it. So we need a logical conclusion as in where do we stop the testing and what is the total cost involved, what are all the tools that you require, what are all the training that you require. In short, if I have to tell you, if the test planning is done perfectly, the job is well done. It will be definitely completed properly. If you plan the test planning phase in a very poor manner, it is going to hurt you badly in the subsequent stages. So what is the first level? The first level is requirement analysis. The second level is test planning. Now what is the third level? The third level is test case development. What do you mean by test case, sir? Very simple. I will tell you what is the environment to be set up, what is the expected result, what is the input, what are all the prerequisites to run the test case, and when it would fail, what is treated as fail, what is treated as pass, and I will have to automate it in case it is needed. That's all. A test case will tell you what to do, how to do, what is the input, what is the output. If the input is giving you the correct output, it is a pass test case. If the input is not giving the expected output, then it is a fail test case, and you will have to write this as a very clear test case document. Sir, how do I write it, sir? I will show you one at the end of the session. Maybe next few minutes you will be able to see that. So please understand, the entire testing will fail if you do not have right test cases identified. If you have right test cases identified, you will get the right results. It is like you getting the right combination of the team for your cricket to be played. If you have wrong players, the team won't work. So test cases are like players. You need to get the right combination of the test cases for you to get right results. Well, this is how the test case will look like. You need to identify what is the test case number, what is the title for the test case, checking the logging functionality for a software, configuration details, what are all the configuration that you will have to do before you go ahead with the testing. I may have to install some software, I may have to free from memory, I may have to free some memory, I do not know what are all those, so I need to mention that. What are all the prerequisites? You must have already started the machine, you must have already loaded some software, you must have already got some results done, so all these will become prerequisite. Now you can describe the test case. Load this, load that, give the input from this level, see if output is coming, check if the level is 1 or 0. Likewise, you need to write it in a very detailed manner, and you need to put the expected results. Expected result, the system should throw an error or system should give a result. Status of the test case should be mentioned as pass or fail. The software detail, which version software did you use? Version 1.0. Like your Android updates which are coming to you in your mobile phone, we need to clearly mention it. And in case you find a bug, you need to mention clearly as defect raised. The defect number would be there, and also you can mention the severity of the bug. Is it a normal bug? Is it a serious bug? Or is it a very dangerous bug which has to be immediately solved? So understand that. Now, what are all the steps we have cleared already? We have cleared the requirement analysis, we have checked with the test planning, the test case development, and then the test bed setup. What do you mean by the test bed setup, sir? Very simple. I need to run my test case, for example, with an Arduino board and sensors connected to it. If I set it up right, if I connect it up right, I call it test bed. This is going to be the spinal cord for the entire process. I need to get my setup clearly done, where I can give the input, I can see the output, I can see if things are getting processed, and this is the place where you run your test cases. That's all. So I need the setup. Setup is like the cooker and the gas stove where you are going to cook your items. If you do not have a proper cooker and if you do not have a proper stove there, you cannot make food. That's as simple as that. So the test bed setup is very important for you. Now, what is the test execution? Very simple. I have already got the test cases available with me. So I will now go through step by step of the test case, and then I will run the test case through step by step as I told you. And once I find out if the test cases are running fine, I will pass it. If they are failing, I will fail it. And when I fail it, I need to categorize the results into minor error, major error, or critical error. This is very, very important. Minor error will be like some variable issues and all. Major error will stop this program from running, and critical error could stop other programs also from running. So you need to identify the priority for the bug that you have identified. That is very, very important. And finally, closing. I have run the test cases, I have seen all the test cases, I have tested it, I have summarized it properly, and this entire things are to be closed in a proper manner with appropriate documentation. I need to document. I need to have proper learning summarized. When you run test cases, you would have learned something new. So document it properly, and overall, if you see, we have completed all the 6 phases of the software testing life cycle: requirement analysis, test planning, test case development, test bed setup, test execution, and closure. That's all. I have told you that very clearly in these things. Now, what are all the types of testing that are available? Let me go through it little quickly. The first one is the manual testing. Very simple. I am going to test everything and anything. So I have a product with me, be it software or hardware. I am going to test it. I will assume myself as the end user, and I am going to test the product end to end. I'll assume all the scenarios, I'll test it. You are like, you should put yourself into the shoes of the person who is buying it. You should think yourself as a customer. So what are all the scenarios that the customer will check? So this is a very important type of testing, and this testing will enable the tester to assume himself as the end user, and he can test. So he will go ahead with all the test cases that are available for manual testing, and this will not use any scripts. It is going to be 100% manual, and you are going to run it through. You will have to be very watchful for running it. Now, when I am doing it, when I go ahead with the manual testing, what are all the things that I need to think about? The first thing that I need to think is, does the software work? Are we designing the product which is working? Second, is it scalable? Today I have 1 input to it. Tomorrow if I have 10 inputs to it, will it work? It should work. Tomorrow I have only 5 inputs. I am scaling down. Will it still work? It should work. So I will test it that way. Does it affect the existing code? Well, you are adding a small module into your system. Will it affect the existing code? No, you need to see that. Will the end users find it very easy to handle the system? You have got multiple apps which are very famous. WhatsApp is very famous because it's very easy to use. Very simple. The UI is very simple. And the most important point, have we cleared all the bugs that are intimated by the testers in the early stages? I have got the summary of bugs with me, summary of errors with me. All those are cleared. Have we cleared all the bugs and defects? And once we do that, I need to say as a manual tester that I can release the product right now. So I need to say, shall we release the product? So this is the role of the manual tester. Now what is automated testing? Very simple. I have got a scenario, and the scenario is to check login and logout. I'll type the password and username. I need to log in. I need to do this for 100 times. I need not go ahead with the manual testing. I do not have to waste resources spending time in typing their username and the password, and it's waste of time. There I can automate it. I need to give values from 1 to 100 to the system to check if it is taking in. I need not enter 1, 2, 3, 4, 5, 6 till 100. Instead I can automate it. So where and all you need a lot of repeated things to be done, you can automate it. Where and all there is only a limited amount of time available for you to test. I have no time available. Can I automate it? Yes, go ahead and automate it. Wherever the requirements are really static, it's all stubborn static requirements, and minimum manual intervention is required, I can go ahead with definitely automation testing. Sir, how do you automate, sir? We have got shell scripting, we have got TCL/TK, we have got Python. We can use all these to automate. This is done in order to reduce the manual effort and also the cost factors involved towards the recruitments and to manage people. Also, when you go ahead with doing the automation testing, the chance of errors are less, because manual errors are always there, but when you go with automated testing, you have very limited chance for you to fail. Now, testing methods. This is a very, very important question, and children, please listen to it carefully. There are 3 types of testing that we normally go ahead with: black box, white box, and grey box. What is black box? Very simple. The box itself is very clear. I do not know what is inside. I do not know what is inside the software. What kind of logic is inside? What kind of structure is inside? What kind of technology they have used inside? I really do not know. But I will have to test it as a product. Black box will keep this software as a black box, and the tester will have to test for the functionalities. I mean, the tester should assume himself as an end user and he should test the product. That's all. Very simple. I do not have to check the internal logic. I do not have to check how the code is written. I do not have to consider the structure of the software, and this is called as black box testing. What is white box? The white box is very critical and exhaustive testing. The user, I mean the tester, will even go ahead towards the core testing of the logic used, the internals used, the structure, the complete functionality, all the aspects of it, including where the memory is released, the way the memory is used, all the function calls, the time taken for the function calls, everything. You tell anything and everything about the software, it will all be tested very clearly, and it is called white box testing. What is grey box? When there is black box, when there is white box, obviously there should be grey box. So what is grey box? Very simple. The grey box testing is in between the black box and the white box. The testers and developers and the end users are all involved in this process, and test cases will be written clearly based on the data flow diagrams, and this testing would not consume much of the time. Okay, so please understand that here there is a partial knowledge required about the internals, and you can go ahead and test it. So this won't take much of the time, as literally you can see that we are not going to go in depth into the process, right? This testing won't consume much time as white box, or less time as black box testing. You need to understand both the scenarios. White box is complete internal checking, even the black box is at a higher level, at like an end user you are testing, so it would be in between. That's what I tried to convey, and I hope you understood it. Right. Now, let me tell you what are all the levels of testing. I'll quickly go through it, since I know that we are running out of time. I'll quickly go through it. There are 5 types of testing that is very common: unit testing, integration testing, system testing, acceptance testing, regression testing. What is unit testing? Very simple. I have designed a mobile phone, and the mobile phone has got multiple modules: calls making, calls attending, internet browsing connectivity, battery, camera, video recording, power, MP3, MP4 playing, video playback, and multiple. All these are to be seen as individual units, and if you test these individual units, you can call it as unit testing. I'll have multiple testers playing a role. I mean, the developer, whomever is developing these modules, can themselves go ahead for testing it. Sir, I cannot understand, sir. Very simple. This is the smallest unit in the entire body. If you test this particular organ, if you test this particular place, we can call it unit testing. I make it very simple. Now, what is integration testing? Very simple. I test your entire leg, then I call it integration testing. Can you give me an example, sir? Very simple. I combine the camera, the video module all together, and I test the entire camera functionality and video shooting functionality. I call it integration testing. This is called integration testing. Well, what is system testing, sir? All the modules are integrated. I test the whole body. Now this is a whole body checkup. That's it. This is going to reach the market now. When I complete this testing, I need to say that, well, this product can reach the market. That is system testing. Regression testing, this is a very important terminology to be understood. What is it? Very simple. We need to keep testing the product continuously until the product settles down in the market. What do you mean by that, sir, and why do we need to do it? If you see an Android app, you get updates consistently. So those updates could affect, or those updates could make the system go slow. So I will keep checking it even after the product is released in the market, because I keep getting updates. This kind of testing is called regression testing. What is user acceptance testing? Testers or developers need not just go ahead with testing it. The customers, the end users, the vendors can also test it. So if the end users are testing it, and if they are finding out some bugs, you should be ready to definitely identify that. So it's something like the end users themselves are testing the product, and it can be conveyed like this. When the software is ready in the hands of the developers, and if it has gone to the tester side, and if the tester has done everything with it and they are okay with it, system testing is done, everything is done, they can now assume themselves as the end user, as a customer, and they can do the user acceptance testing. Or even it can go to the market and you can get the reports from them and you can keep fixing it. That's also possible, and many errors are fixed which are notified by the customers only. This is called user acceptance testing. Well, please understand the difference between testing and debugging. Testing is to identify bugs. Testing will uncover all the bugs. What is debugging? Debugging will help you in fixing the bugs. That's all. Now you take the tire is not working fine. The tire has lost the air inside it. So what do? I test with the monitor. Now this is testing. I am testing the tire pressure. It is found to be low. Now I debug. where exactly the problem is available in the tire. I found that there is a nail which is troubling the tire, and I now remove it, I fix the puncture, and that is called, this process of identifying where the error is called as debugging, and then you need to fix it. So this is a very important interview question. What is the difference between testing and debugging? Well, when do we stop the testing, sir? Very simple. The deadline has come. I need to release the product. No other go ahead for it. No more bugs, sir. I am 200% confident. My software is working fine and I have no bugs. There you can go. I have no more money, sir, to go ahead with testing. Go ahead. The requirements are met, sir, fairly. I do not have any problem. You can go ahead with it. That's all. Now I will show you a test case very simply. So please go through it. This is a very important thing. See the details that are available here. Project name. What is the name of the project? Test case ID. Function underscore test underscore 01. Title of the test case. Login success message. Product module. Version. Date of design. The tester's ID. Who is the author of this module? The revision. If you are writing the test case for the second time by correcting it, you need to mention as revision detail. The tester ID. Who is testing it? Priority. Low, medium, high. Which is the priority of the test case? Description. You need to say that what are all the assumptions that are available here, what are all the preconditions that are available here, what are all the execution steps that are available, and expected outcome. What are all the expected outcome? Result. Pass or fail. Severity. If it is fail, I need to say it has minor, major, or critical error. Date of execution. When did you execute this? This much detailed analysis has to be presented in the test case. The test case structure is so very important, and it is very important for somebody to write and follow test case in this way. So tomorrow what I am going to do is, there is a session which is planned to be conducted tomorrow, and I will talk about the good versus bad test case. I will tell you how exactly to write a poor test case and how do we write good test case over it. And with that I complete today's discussion, and I hope you liked it. In case you have questions, you can ask me right now. I hope I did not bore you people. In case you have questions, please go ahead and ask me. I'll be very happy to answer.